Assalamu alaikum students. Today's our lecture is about decoder, encoder, mux and demux. Decoder. What is decoder? It's a circuit that has n number of inputs and 2 raised to power n number of outputs, and outputs 1 on the output corresponding to the binary number represented by the input. यानी कि इनपुट कॉम्बिनेशन की बेसिस पे हम डिसाइड करते हैं कि आउटपुट पे कौन सी आउटपुट पे हमें हाई लॉजिक जो है वो मिलेगी. Now there are several types of decoders. All cases, a decoder is an electronic circuit with multiple inputs and multiple number of outputs. It converts every unique combination of input states to a specific combination of output states. Let's say for example 2 to 4 line decoder. It means it has 2 inputs and 4 outputs. Now each unique set of inputs will activate only one output. Now check this combination. If you look at here, you have 4 combinations: 0 0 0 1 1 0 and 1 1. If you have 2 inputs, then you will have 4 combinations, and you have 4 outputs. For 0 0 combination, D naught output will be high and all 3 outputs will be low, and for 0 1 combination, D1 will be high and remaining 3 D naught, D2 and D3 are low. For 1 0, D3 will be high, D2 will be high, D naught, D1 and D3 will be low, and for 1 1 input combination, D3 will be high and D naught, D1 and D2 will be 0 or low. This is the mathematical expression for all outputs respectively. D naught representing 0 0, D1 representing 0 1, D2 representing 1 0 and D3 representing 1 1. This is the circuit based on representation of output equation. Here you can see D naught x complement y complement, D1 is xy complement, D1 is x complement y. Okay. So according to this mathematical equation, you will have to draw the diagram of decoder. For 3 to 8 line decoder, you have 3 inputs, and you know that if you have 3 inputs, then you will have 8 combinations. So you can have 8 outputs. 2 raised to power 3 is equal to 8, and to 2 raised to power n. So you can see that for 0, D naught is high. For 1, binary 1 and 0 0 1, D1 will be high. For 0 1 0, D2 will be high. For 0 1 1, D3 will be high. For 1 0 0, D4 will be high. For 1 0 1, D5 will be high. For 1 1 0, D6 will be high, and for 1 1 1, D7 will be high. This is the respective table. These are the equations, the respective equations for outputs from D0 to D7. Like for D3, you are having x complement y z. So this is the logic diagram for decoder. All these mathematical combinations are implemented in this logic diagram. So symbolically, decoder is from n to 2 raised to power n number of inputs and 2 raised to power n number of total outputs. Second is encoder. Encoder is a circuit which works in opposite manner as that of decoder. Here we have 2 raised to power n number of inputs and n number of outputs. So we need to design both encoder and decoder. 4 to 2 line encoder and 8 to 3 line encoders are its type. Now applications, the decoder will be used: TV remotes, telephone systems, computer bus, secret coders for other specific applications. Next is multiplexer. Multiplexer is a combinational circuit that selects binary information from one of many input lines and direct it to a single output line. Now selection of particular input line is controlled by a set of selection lines. Normally there are 2 raised to power n input lines and n selection lines, whose bit combinations determine which input is selected for a particular case. So MUX has multiple inputs but only one output. It would be known as many to one. Now 2 to 1 line MUX has 2 inputs and one output. Each unique set of inputs will have only one output. Let's say you have selection bit S and you have two combinations, you have two possibilities, 0 or 1. For 0 it will select output A, and for selection bit 1 it will select output B. So the truth table of Y is equal to A complement S plus B dot S. It is based on this truth table. So this is the respective circuit for MUX. Here you can see you have two inputs A, B, but selection bit is S. If you want to select A, then S complement will be applied to the logic diagram. Here there is a mistake. Complement will be placed at S, not at A. Okay, if you want to select A, then S complemented output will be supplied to this logic gate, and if you want to select B, then S will be applied to this AND gate and B will be at the output. So this is the symbolic diagram of MUX. A, B, selection bit S and output Y. 4 to 1 line MUX. It has 4 inputs and 1 output. Each unique set of inputs have only one output. Now you have S0, S1 as selection bits. You have 4 combinations: 0, 0, 0, 1, 1, 0 and 1, 1. For 0, 0 it will select A, for 0, 1 it will select B, for 1, 0 it will select C, and for 1, 1 it will select D. So these are the input combinations related to 4 outputs. Here you can see S0 and S1 complement are related to A, S0, S1 complement related to B, S0 complement S1 related to C, and S0, S1 related to D. Now 4 to 1 line MUX is represented here. Here you can see for A, both complements are attached with AND gate. For B, S0 complement is attached with the AND gate of B, and S1 is attached with AND gate of B. And for the case of C, S0 is attached with AND gate, and S1 complement is attached with C. and for the case of D, S0 and S1 are attached with AND gate of D, and we will get output from the OR gate. This is a symbolic diagram of port 1 line mux. A, B, C, D are inputs, and S0, S1 are selection bits, and Y is the output. So mux has multiple inputs but only one output. We can also have 8 to 1 mux, 16 to 1 mux. The applications again: TV remotes, telephone systems, computer bus, and secret coders. That's all for today's lecture.